G'day, it's Presto. Welcome back to the shop. Now, I'm starting a new video series today, and it's probably the most ambitious machining project I've ever undertaken in this shop. And the backstory to this is that I've been following a channel on YouTube quite a long time now. It's called Threadexpress, belongs to Cliff Hall. He's a toolmaker that lives in New Zealand. And just recently he started a series of videos where he was showing the capability of a machine that he's developed called Threadexpress. Now, it allows an operator to be able to carry out thread milling operations on a knee-type milling machine, and it's got some excellent features, and it's quite a capable little machine. Now, when he started to reveal how it worked and what the internal mechanism looked like, I took a look at it and thought it was probably something that I could make myself. But unfortunately, he wasn't showing the entire mechanism because he was trying to protect the intellectual property on this invention that he come up with. Now, I got in touch with him and I asked him if there was any way that I would be able to get hold of the drawings and be able to make one myself. And long story short, we worked out a deal. Now, the deal is that I was going to create all of the 3D models and the 2D drawings for this machine and all its parts in return for the actual guts or the innards of how it all operated. Now, I've been working on that process quite a long time now, and I've got all of the design CAD modeled, and I've done most of the 2D drawings. And the deal was that when I finished all of that process, I'll send the drawings back to Cliff, and he is going to look at the idea of actually selling the drawings so that anybody like me could make one of these Threadexpress machines. Now, just so you know, this is Cliff's homepage on YouTube, and these are some of the videos that he has released. And it's an excellent channel and it's well worth a look at. I'll put a link in the description, and there's also a link up above there now if you'd like to take a look. Now, the Threadexpress machine is actually an accessory that fits onto your milling machine. It's not electrically powered, it's entirely manually operated. And it's able to cut threads from around about M3, that's about 0.5 millimeter pitch, up to around about 3 millimeters in pitch. And it's also capable of cutting both metric and imperial threads. It will also cut internal and external threads. Now, the internal thread size is limited by the actual size of the cutter that you can fit inside the bore. But for external threads, you can cut up to, I'm guessing, around about 300 millimeters diameter. So it's very, very versatile in that sense. Now, it also allows you to be able to cut a thread up to a shoulder and stop precisely at a single point. Now, for someone like me, I'm doing single point threading on the lathe, it scares the living daylights out of me when I have to be able to cut the thread up to a shoulder. But with the Threadexpress, because it's manually operated, you can stop the cutting operation very precisely right up against the shoulder. So all of those sort of things attracted me to the idea of actually making one of these myself. Now, I've got a whole bunch of stuff on the bench here that I want to show you, and this is what I've collected to this point so I can start this process of making the Threadexpress myself. So I'll have a look at that, and then we're going to look at a couple of the operations for making one of the important parts of the Threadexpress, which is the headstock assembly. So let's have a closer look at what's on the bench here, and we'll talk about where we're going from there. Now, because the Threadexpress machine is quite a complex build, there are quite a lot of off-the-shelf parts that you'll need to accumulate before you start, and there are a lot of stock materials that you need as well. But I'll talk about the off-the-shelf parts first. Now, nearly all of this stuff came from AliExpress, and I'll be providing links in a document if you're deciding to build one of these yourself, and you can find the parts on AliExpress. Now, one of the most crucial parts of the whole design is this set of bevel gears. Now, this is a 4-to-1 reduction and a 90-degree bevel gear set, and this allows you to rotate the workpiece by hand. So this gives you quite a measure of control when you're moving the part past the fly cutter. These were induction hardened when I got them, but they need to be machined, especially this bore in the center of this larger gear. So in order to be able to do that, I annealed these in my powder coating oven. So they went into the oven at 250 degrees C. I let it soak in the oven for about 40 minutes, and then it cooled down in the oven, and these are now soft enough to machine. Now I also bought a 100mm 3-jaw chuck. That's just a cheap one. The back plate, I've machined that up already from some scrap that I found in my scrap box. The chuck back plate actually has a thread on the inside there which allows it to screw onto an ER32 collet chuck. So when my version of the Threadexpress is finished, it will be able to grip work using either the 100mm chuck or an ER32 collet system. So that's a new feature that Cliff has added to the design. Now you also need some bearings. These are the bearings for the main spindle. These are angular contact bearings. This one, the larger one, is for the top of the headstock which carries the spindle. The smaller one here goes to the bottom. Now as it turned out, I bought the incorrect bearing and I've had to buy a second one with a 25mm inner ball. Now the good thing is that these bearings do very little work. They're really just to hold the spindle in accurate alignment. Because everything is hand operated, they never run fast, they never run hot. Lubrication is probably what's already in them, that will last forever. So they don't need to be terribly high quality bearings, but that's what I got there from AliExpress. Now in order to move the bevel gear assembly, I bought this 100mm hand wheel. This is just a cast iron one. Now, you don't have to buy it, you can make it out of anything. You can make it out of a bit of wood if you really wanted to. But these were relatively cheap, so I just bought one off AliExpress. Now in order to support the pinion on the bevel gear set, I've just got two 6000 series 2RS ball bearings. Once again, these never really run very fast. There's almost no load on them. So these are just, again, for keeping everything in alignment. Now I also bought this 18mm long series drill bit. This is to drill a bore up the center of the spindle so you can pass long bar stock through the spindle. Alright, so there are all of the off-the-shelf parts. Let's have a look at some of the materials that I've found in the scrap box and what I've had to buy. As you can see over here, I've got quite a lot of aluminium plate stock. Now this is not all of it. I've got two pieces still coming. And as it turns out, a lot of this is actually excess to what I need. So this great big block here, I only need this small part off the end here. So everything else is going to go into my stock and I'll use that for other projects. So when I talk to you about the budget, although it seems expensive, it's because a lot of this stock here is excess to the requirements for the Threadexpress build. So this is all various thicknesses and widths of just 60-61 aluminium bar stock and plate stock. I already had some of this in my supply, so this bit of 6mm already had that, but everything else I've had to purchase. Now there were other parts that need to be made from aluminium plate stock, but in order to cut down on costs I'm going to make them from castings. So this pattern here is for the bearings that support the pinion on the bevel gear drive. This large piece here is going to be bolted to the back of the milling machine table, and that pocket on that side there fits over the coolant drain. So this is actually custom made to suit my milling machine. And once again, it's a big chunk, so I thought it's easier to just make it from a casting, or cheaper anyway. Now this one here is the casting for the headstock, and the bearings will actually go into these what will eventually be cored holes in the casting. And I need two of these, one for the top, one for the bottom. And I've actually made separate core prints for two different size bearings that I need. These are the 3D printed core boxes. This is one of the cores, and I've got the other one here ready to be extracted. And actually the first thing I'm going to do in this build is actually make all of the castings, so you can have a look at how that works. Now, as well as the plate stock and the castings, there's also some bar stock required. Now this is the actual rough turned spindle for the Threadexpress. Now this carries the chuck, either the 100mm chuck or the ER32 collets, and it has mountings for bearings at both ends. And this was actually machined, it's just rough machined at this stage, from some chrome bar stock which I already had. Now this stuff is actually quite tough. It was quite a struggle to machine it on my Colchester, and I made lots and lots of blue chips and I've got the scars on the back of my hands to prove it. but I already had it, so I just decided to use that. Now I needed to buy some bronze stock. This is for the nut on the spindle. This is one of the parts on the pitch generating mechanism. And I also had to buy this piece of cold rolled steel. This is also part of the pitch generating mechanism. And I found this rusty old bit of angle iron in the scrap box. This is for one of the minor parts. Okay, so I'm guessing you're wondering what the actual cost is. Now I've done a spreadsheet here just to keep track of my own costs. Now the total of what I've spent so far has been $693. Now that's Australian dollars, and that's not really a true reflection of what the Threadexpress is going to cost me, because like I said, some of this aluminium plate stock is excess and it's going to go into my scrap box, but that's the total that I've spent so far. Now for all of the aluminium plate, that was a total of $406. For the other stock, that's the bronze, the bright mask steel and so on, that was $70. And the off-the-shelf parts, including the chuck, the gears, the bearings, the hand wheel and so on, was $215. So yeah, it's a sizable investment for a project that I'm really building just for the challenge. It's also going to be an extremely useful thing to have in the workshop, but what got me interested in the whole process was just, I don't know, just looked like a fun, interesting, challenging sort of build that I'd like to have a go at. Now, I'm not sure if I mentioned this already, but I've been doing all of the 2D drawings. So I've got lots and lots of sheets of drawings, and these are going to get released at a later stage. These are very much in draft form at this point, and as I go through the build, I'll be editing the drawings and adding things and correcting mistakes and so on. So I'm sort of the guinea pig. I think I'm the first person to actually build one of these Threadexpress machines. And as you know, a result of that, there are things that I don't know. There are things I'm going to find out as I go along. And although Cliff has been very helpful in giving me tips and information about the build, it's still a process of discovery for me. But eventually there will be around about 16 to 18 sheets of drawings. Plus there will be a parts list. There will be a budget, and also just links to web resources if you need to buy parts. All right, so thanks for sticking with me. I know that's fairly long-winded, but it's a really broad topic, and I said to Cliff this morning I wasn't sure how I was going to do this. I'm really just sort of making up this sort of introduction as I go along. But what I want to do now is get these castings made, and the first part of that process is to extract this core from the core box. So let's have a look at that. Now here's one I made earlier. This is for the larger diameter bearing on the top of the headstock, and these core boxes are 3D printed in PETG filament, and the only preparation I did on these was to sand away any of the little knobbly bits on the inside of the core box, and then they've been coated with a beeswax and carnauba wax mix. Now I use this stuff, but basically any wax will do. And it's just coated fairly liberally onto the inside of the core box, and that allows the core to release very easily. Now the cores themselves are made from just ordinary dry fine white sand and about 8% epoxy. Now you can use just about any epoxy that you want. The stuff I use is a clear casting epoxy that I bought for another project, and you just weigh out the sand that you need, calculate how much resin you actually need, and mix it up. Takes about 24 hours to set and cure really hard, but I love these cores. They're very strong, very tough. You can sand them later on to smooth off corners and edges and so on, and they work perfectly when you're casting in brass and aluminium. I've never tried them in iron because I don't cast iron at home here, but that's the bigger one. So let's get this guy out here. So I just held these together with tape. And you just put a knife down there, and it separates really easily. And I've got some dowel pins there to hold the two halves of the mold together. When you get to here, I just give that a light tap. And there it is. Now there is a little tiny flash line on there, but that sands off very easily, and that is going to form the core for the smaller bearing on the bottom of the headstock. I've got the pattern ready now, and I'm putting this into the drag, and the way it's going to go in is unfortunate, but it means that the core print is going to have to go inverted. It's going to go into the drag with the skinny end down, and what that means is that when you go to assemble the cope on top of it, it's got to find that larger diameter and sort of guide itself down without knocking it off its alignment. Now I can actually invert everything, which is probably how I'll do it. I'll flip the whole mold over so that this is sitting in the cope with the big end down, and then I'll lower the drag onto it. I think that's the better way of doing it. Now, I'm only going to do one of these. They're pretty much identical apart from the size of the core, and the other moulding box that I need to do the second one of these being used for a completely separate project. So yeah, we're just going to do one. Okay, so far so good. We'll get the pattern out and clean up the in-gate and the connection to the riser. So hopefully this pulls out clean. So I clean out the connections now, and everything inside there looks great. And then we've got to try and get the core in, but like I said, I think I'm going to invert it and do it in the cope first, lower the drag onto the cope. So here's our core, and with my very shaky hands I've got to lower that in. God, that's hard. Okay, so that's seated there, and now we've got to lower the drag over that, and hopefully this little taper on the end of the core is going to help guide it all together. Alrighty, I think that's good to go. This is the mould that has the pinion drive casting, which is quite small, and also the big mounting plate that goes on the back of the Bridgeport table. And it's got a large projection that sits down below the surface of the cope. And if I lift the cope off, there's every chance that that projection will just simply fall off under its own weight. Now, someone with a much bigger brain than I have gave me a tip and said, if you're going to do this, flip the mould over and take the drag off, and that will leave the piece that would normally be hanging down sort of supported. It'll be upside down. So we'll see how that goes. Sort of makes sense, doesn't it? Okay, so now we have the drag on top, and we should be able to lift that up, and that will leave that lump of sand in the cope, I hope. Okay, pretty good. So if I had done this conventionally and lifted the cope off, there's a chance that this piece would have just fractured off and stayed in the pattern, which is over here. So it's left a little bit of sand stuck there, but that's going to be fine. So yeah, thanks Tobo. I think this one filled fine. Something went wrong with this big one. That was the plate that fits on the back of the milling machine table and the little pinion drive housing. So not sure what happened there. I'll probably have to do the pinion drive housing again. It's a fairly small mould, that should be fairly straightforward. So let them cool a bit and we'll break them out and see what they look like. Alright, I'm sort of expecting this is going to be a fail, but we'll see. Maybe not. Alright, I think that's worked. And why is there no riser on that little casting? Did I forget to connect that? I bet I did. God, you're an idiot, Mark. Anyway, the casting has actually worked, so I think we're good. I'll get this one cleaned up, we'll have a closer look. Probably a bit of shrinkage just around the riser here. Whew! You get a win every now and then. Okay, so this is our lower headstock end plate, the one with the core. So far so good. I'm going to leave that core in there because I don't really want to contaminate my green sand with the epoxy residue and the burnt resin. So I'll get that out separately, but it all looks good. Now I've got one more of these to do. Just so I give you a look at these castings, I've cleaned off the gates and given them a bit of a grind. This is the main mounting plate that the Threadexpress will bolt to on the back corner of the Bridgeport table. Now these angles will eventually get machined off and they'll be machined into an arc, and that's a scale so that you can tilt the headstock of the Threadexpress over to the helix angle of the thread that you're cutting. It's generally between 1 and 3 degrees. But this pocket on the back turned out great, and this is where the drain comes out of the back of the table. It'll eventually drain out through the bottom of the casting here. Now there's a lot of shrinkage on the back of this, but that's okay. I allowed for a lot of machining allowance on all of these parts, so that'll be fine. Now this is the casting for the pinion drive on the 4:1 bevel gear reduction. This turned out great, and I was completely puzzled. I didn't know why the metal wasn't coming up through the riser, and just old dumbass here forgot to connect the riser to the cavity for the casting, but the sand is permeable enough for the air to escape, so that casting's turned out just perfect. Now this is the end plate for the headstock, and this is where the cord hole was, and these always turn out absolutely fantastic. I'm absolutely blown away with how good they are. Now this one here, I haven't removed the epoxy from that yet, or the sand and epoxy mix, so I want to show you how easily it comes out. And it's just like that, and you can break it up if it's a complex shaped core. You just smash it up with a hammer or a screwdriver and it comes out really easily. So it's as simple as that. Now I know people are going to tell me that you can use sand and sodium silicate and you can harden it with CO2 gas, but for me I just don't want to have another cylinder of gas in the workshop. There's just no room for it, and it's just an extra cost, whereas the epoxy and the sand are dirt cheap. So that's what I use, and it always works well for me. So I'll get this one cleaned up and then we can start the machining on these. But yeah, that's like a day's work, and it saved me a lot of money. You know, these castings only cost me the price of a little bit of diesel fuel. So yeah, let's keep going. Just to finish up today's video on this Threadexpress build, I thought I'd show you the parts that I've got finished to this point. Now you've already seen this main spindle here. This is only rough turn at this stage, and on the drawing there are a lot of details that need to be added to that rough turn part. So I'll get on and do that in the next episode. There's also a threaded nut that goes on the bottom of the spindle here, and that compresses the two angular contact bearings to keep everything in alignment. So although that looks you know, complex, a lot of it's just accurate turning. We need to get the linear measurements correct. That's really important when you're dealing with angular contact bearings. And the fit of the bearings on these journals at either end here needs to be a sort of like a light running fit. That's as far as we need to go with that. So that's going to be coming up in the next episode. Now these two castings here have been machined, but not all over. I still haven't done the pockets for the bearings yet. And despite my best efforts, I did get some shrinkage on these castings. You can see that there. And I can fill that with JB Weld. These parts will be sandblasted and powder coated later. And although that's just a cosmetic failure, the important bit is just around this mounting for the bearing here, and that's all solid metal, so that's fine. A little bit on this corner here is missing, and these are just straight off the mill. I haven't done any finishing work on these at all yet. This one turned out a bit better, better surface finish on that one there. And I didn't show all of the machining operations for these parts because a lot of it is just repetitive cuts and setups that are fairly basic. You do need to be fairly accurate to keep the parts square, and I did that by mounting the parts on an angle plate. I had fixture blocks to ensure that I could swap out the parts there and keep the ends square as I machined these end plates for the headstock. On this big mounting plate here, this was done mainly on the rotary table. So the big arc that you can see around here is for a scale that will allow me to tilt the head of the Threadexpress overlader to the helix angle for the thread that you want to cut. And these curved slots here also done on the rotary table, and these are to clamp the headstock in position once you set the helix angle. So again, pretty straightforward sort of machining operations on this, and again, I haven't done a lot of cleanup on these parts yet. And I'll show you where this goes on the milling machine shortly, and I'll tell you about a, a failure already this close to the start of the build, but it'll work. That's going to be fine. The back plate for the 3-jaw chuck is done. This index ring around the outside here is so that you can use the Threadexpress basically as an indexing fixture. So if you want to machine, say, hex-headed bolts, or if you want to machine grooves or a finger screw or something like that, you can get up to 12 divisions around the outside of this index ring, and it can be moved and reset in any position that you like. So that's just an added feature of the Threadexpress, that it will operate as a sort of an indexing head as well. This is the back face at the right hand end of the mill table on the Bridgeport, and this tube here is for the coolant drain. And when I was designing this casting here, I was working to the sketches that Cliff sent me, and the deal always was that I would make all of the parts exactly the same as the sketches of his original invention. And in order to make it fit on my machine, I cast that pocket in the back of this part here to fit over that drain, and there would be an alternate drain coming out through the bottom of the casting. Now, as you can see, there's not a lot of room there because of the cover over the glass scale on the back of the mill table. Now, your mill might be different. In fact, Cliff's mill is not a Bridgeport, it's a Bridgeport clone. And when I had made the pattern, I brought it down here and held it up over that drain there, and I thought, no, it's all going to work, there's plenty of room. And what I hadn't considered was that this plate, which is actually called the main slide plate, has to bolt onto that casting, like so. And you're able to actually tilt that main slide plate over to the pitch angle of the thread that you want to cut. Now again, I sort of figured that that was all going to fit, that wasn't a problem, but I had forgotten that the headstock assembly has to slide up and down this plate here, and there are a couple of linear guides, or a linear guide on both sides. Now the linear guide is going to clash with that cover there. So it was just one of those cases where you're sitting up upstairs in front of the computer and you're looking at a model on the screen, but you're not standing in front of the mill here. Now it turns out that I can fix it. What I will need to do is to make a spacer plate about 12 millimeters thick to go between this face of the mill table and the back face of that casting, and that will bring everything out just far enough to clear the cover over the glass scale. So yeah, it's annoying, it's something I hadn't considered initially, but it can be fixed. Anyway, let's go back over the table and we'll finish up for today. Now, this Threadexpress is only one of Cliff's inventions. Now, he also sells a product called the Hallmark Impact Tolerant Touch Probe. Now, I'll put a link in the description of this video, but the Hallmark ITTP, or Impact Tolerant Touch Probe, is exactly what it says. It allows you to crash a probe into a vise or a piece of stock and it will survive. And normally these things are very delicate. If you crash it into something, there's a fair chance you'll bend or break the probe, or you'll damage something internally. But Cliff's invention gets around that. There are some very clever internal parts of that device that allow you to basically abuse it and it will survive. Now, where are we going with the Threadexpress? Well, in the next video I'll do some more parts on the headstock of the device, and I'll be doing most of those parts in a fair amount of detail. Now, you need to understand that this is not my invention, and I'm not the one that should be divulging exactly how it works. That's up to Cliff. So he will make the decision about how much he wants to show about how it works and where it's going to go after that. Now remember, he's still looking for a buyer for this device, and if somebody out there thinks that they would like to take it over and run it as a money-making venture, then Cliff's open to that idea. Or the other option is that Cliff will just sell the drawings either by a fixed price model or maybe a donation model. We're not quite sure how that's going to work yet. But yeah, tune in next time, we'll look at some more of the parts. And even if you just come to just watch the machining, that's fine. I reckon that's probably a worthwhile way to spend your time. So tune in for that next episode on the Threadexpress. I've got some wildlife footage to show you, and then I'll check you on the next video. It's Prezzo signing out now. Cheers.